Hello students, today we are going to start another chapter. Chapter name is Atomic Structure. It is our third chapter according to content list. So let's start by calling the agenda of today lecture. We will study about introduction of atom, Dalton atomic theory. Third one is modern atomic theory, and last fundamental particles of an atom. In your previous classes you have read about the definition of atom, but today we will start with the Democrat's theory of atom, which he published in 400 BC. He was the first person who used the name atom and introduced atoms to the world. According to him, all the things which we see is made up with tiny particles. These tiny particles are called atoms. Atoms derived from Greek word atoms, which mean indivisible. It means it cannot be divided into further parts. According to Democritus, the Greek philosopher expressed the belief in the 5th century BC that all matters consisted of very small indivisible particles, which he named the atoms. For example, the fur of an elephant or the parts of stone are made up of atoms. After many centuries, John Dalton in 1807 was the first person who published a new theory about atom. He was a science teacher in England. His theory name is Dalton atomic theory, which is world famous due to his experimental approach. After thousands of years of Democritus, he experimentally proved his theory. To understand the atomic structure, Dalton atomic theory postulates are given below. Number 1. All elements are composed of atoms. Atom is too small so that it could not be divided further into simpler components. Number 2. Atom cannot be destroyed or produced. Number 3. Atoms of an element are similar in all respects. They have same mass and properties. And the last one is atoms of different elements combine in a definite simple ratio to produce compound. Let's elaborate his postulates one by one. In first postulate, he wants to tell us all the elements are made up of tiny particles. These tiny particles cannot be further divided. These particles are called atoms. In second point, he said we cannot produce atoms or we cannot destroy atoms. They are naturally found in this world. In third postulate, he said all the atoms of an element have same properties and masses. It means gold element has same atoms and silver atom has same atoms. In fourth point, he said all atoms of different elements combine in simple ratio to produce its compounds. Means if water and hydrogen combine, they can produce water, which is an compound. Dalton theory is better than Democritus, and his first two postulates are very good, but in last two postulates he exaggerated. It means his last two postulates are not correct and proved wrong after publishing of modern atomic theory in start of 20th century. According to this theory, his first, second last and last postulate have some defects, and this theory can be read. Dalton atomic theory assumed that the atoms are divisible and no particle smaller than atom exist. But according to modern atomic theory, atom is a complex organization composed of even smaller particles called subatomic particles, for example electrons, protons and neutrons. Dalton's view that all atoms of an element have the same mass is modified in the light of discovery of isotopes. According to modern theory, the ratio between atoms of various elements in many organic compounds is not simple. Let's understand both theories by comparing them. According to Dalton theory, atom cannot be destroyed, but modern theory said we can destroy atoms. In second postulate, Dalton said atom is smallest particle itself, but modern theory said atoms has more smallest particles which are proton, electrons and neutron. In last postulate, Dalton said atoms of an element have same properties, but modern theory said it is not possible that all the atoms of an element is same because the discovery of isotopes changed the approach of scientists. At last, we will discuss about the subparticles of an atom, which are also called fundamental particles of an atom: electron, proton and neutron. The atom was generally identified as the smallest particle of an element consisting of subatomic particles: the electron negatively charged particles, proton positively charged particles and neutrons neutral particles which have no charge. The first hint about the subatomic particles came with the discovery of electrons by M. Faraday 1832, William Crookes 1879 and J. J. Thomson 1897. Later, the second subatomic particle, the proton, was identified and isolated by Goldstein, German scientist 1886, and Ernest Rutherford 1919. Finally, an English scientist, James Chadwick, revealed the third particle, the neutron, in 1932. The structure of an atom, as we know it today, is because of these findings.